This video will present a little bit different type of task, but I hope you will quickly notice that it again comes down to playing with matrices and arrays and using loops and if-else conditional statements. So the idea here is that we would like to make Matlab create an array which looks like this kind of Christmas tree. And we would like this code to be universal, to work for any kind of tree height. So in this particular example, the total tree height is 13. And in any other tree, we would just have this bottom part of the tree looking roughly the same, just that the width would be bigger or smaller. And then those layers in here would basically get adjusted to the height. So the number of layers should be equal to height of the tree, total height minus 3. Alright, so I suggest maybe we first look through some things that might be useful in here. So if this tree has height 13, so if we deduct those 3 layers which will look the same for every tree, what remains is 10. Now out of those 10, 1 is that star on top, but then we have 1, 2, 3, 4, 5, 6, 7, 8, 9 layers which keep changing and being more and more narrow. So if you notice the bottom layer, there are spaces here between those slashes and backslashes. So the bottom layer has width 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and 19. And as we go up, this next one also is 19, so this very bottom layer of this part. But then each next layer, even though the array here has the same width, because there are spaces also on the left and right hand side, then the part which actually has some characters will be decreasing every time, and automatically that will mean that the number of spaces appearing here on the left and right of each tree will be increasing. So there is no space here, there is 1 space here, 2 spaces here, 3 here, 4 here, and so on. So you can see this number is growing. So we realize the bottom layer has 19 spaces or 19 characters altogether. So if we relate it to the level or the layer number, if this is layer 10, if we count from top, so if we do 2n minus 1, that's how we can represent how many things we have in there. In the next layer, we are in layer 9, and there is 1 space here, 1 space here. So now we know that if this layer had 19 characters, this one has 17. So again, 2n minus 1. If n is now 9, because it's 9th layer from top, 2 times 9 is 18, minus 1 is 17. And here was 19. And at the same time, there is 1 space, then there are 2, and so on. So we could also define the number of spaces here somehow using the layer number. So if here layer was the 10th one, the space was 0. If layer is 9th one, there is 1 space, 8th one, 2, and so on. So the number of spaces could actually be, S would be always like complement to the layer number, or the total. So it's 10 minus, and the layer we're in, which is n in here. So 10 is the total height, if we think of it now, and n is the layer we are visiting. So for instance, in this layer, it's 1, 2, 3, 4, 5, the 5th one. So it means that the number of spaces here would be 5, because it's 10 minus 5. And the bottom is always the same, so that can be defined from the start. So you could approach these in different ways. You could start building the tree from the bottom down, or from the top down, or from bottom up. I'll choose the second one. So I'll start from defining this bottom part and then start building it up layer by layer. Also notice that there are spaces in here as well. And there is again, if this star is at the location where is our total tree height, if I will represent it now with capital N, so there is n minus 1 spaces in here, and there will be n minus 1 also on this side. So let's jump to the code. I will make it be a function, but first I'll just write the code so I can run it piece by piece. And then when the code is ready, we will convert it into a function. So I'll start from defining the general variables. So the total tree height, let's use 13, which we have in our case. And then there will be also, I'll call it small n, which will be the number of layers we actually have to build which are changing, because these layers will remain constant. So I'll call it small n, and it's the capital N minus 3, because the 3 layers I'll do kind of manually from the start. So my tree will now, the first part, so the bottom 3 layers will be like this. The bottom layer had, we already talked, n minus 1 spaces first, and I'll use here Matlab's function repmat, where we say what we repeat, and I repeat spaces, and then we say how many times. So I want 1 row and n minus 1 columns of spaces. Then I'm combining string arrays, so I can do it also using this trick that it is actually an array. So then I'll have my star, which is here, and then again same amount of spaces. So this is one layer which has the spaces and the star, and our stem has 2 stars, so I'll actually have to repeat the same thing here. But now above those 2 I also have the layer which has just the dashes, and the number of dashes is the same as the total amount of characters here. So it's n minus 1 plus n minus 1 n plus 1, which we already concluded that it is actually 2 times n minus 1. So repmat, now I'm trying to repeat a dash, and there is 1 row of them and 2 times n, capital N minus 1. Or sorry, small n, that's actually in here small n, because these 2 are off. We were talking that this is related to the number of layers in this green part of the tree. So actually this should be small n minus 1, and the same way I should actually have these as small n, because it was 10. The total. Alright, so now before we proceed, I will run it and we will see how our tree is now looking. So you can see we do have the stem and this bottom part. And now is the time. So this is a fixed part for every tree. The only thing that will be changing here is the width. But now we have to start building that green part which is above those 3 layers. And I will be going from the bottom layer of that green part upwards. So from 10th row, from 10th layer to the first one. And if it's from 10th, so that's my n actually, and I'll be going 1 by 1 down. So that's why my index has to be changing from n with step minus 1 down to 1. And now I have to call it something else, so I will call it maybe k. Alright. And now within that layer, I have to compose a number of things. I have to compose the spaces on the left of my green part, then the green part having the slashes and backslashes with respect to where we are in the tree, and then the spaces on the right hand side. So first I'll define the spaces, and I know that the spaces should be repeated spaces, and how many of them? 1 row. And we already defined in our formula that the number of spaces is actually the small. Now I used a bit differently the letters, but this is our small n in the cone, and then minus the layer we're in, so minus k in here. Maybe I'll change here on the slide so that we are not getting confused every time. This is k, and then this is k, and then also this is k. Alright, so I need n minus k spaces. And this same amount will be on the left and right hand side. So I have it ready. Then I need the green part. And now for the green part, it really matters where we are. So are we having slash? Are we having a space? Are we maybe having the central part, which is this vertical bar? Or are we actually having backslashes, so the other way? So whether it's slashes or backslashes, that depends whether we are on the left or right hand side from the center of the tree. Now, if we think that the number of actual elements in here is defined as 2k minus 1, so I can have another loop now, which for that particular layer is going through places which are here. So I will not touch the places which should have spaces. I will only be going for this number of places from 1 to 2k minus 1. So now k represents my layer, and I will be going for 1. I need another index, maybe I'll call it L, going from 1 to 2 times k minus 1. And now what is happening in there? Well, first of all, if we are on the left from the center. Now center will always be located exactly where K is, because if we are, for instance, it's easy in here. This is second layer. The green part has 3 places, 1, 2, 3, and it's 2 which defines the center. So on the left from 2 there is a space, on the right from 2, there is a slash or possibly a space, then in the middle there could be space or a vertical bar, and then on the right is backslash. So I will need a bunch of conditions in here. First of all, let's stick to being on the left hand side. So if I am on the left from K, so if my L is less than K, then I'll be adding the slash, and let me define actually those 2 characters here so that I don't have to type slash backslash. I'll just call them left and right. So on the left hand side we have slash, and on the right hand side we have backslash. And then we can also define the center being that vertical bar. It's the same character we use for OR, logical OR. And then I'll use SP for space. Okay, so if I am on the left, I will have either a space or a slash. And actually I will use here less equal so that we can also have the central part when we reach particular condition. So now how do we know when to use the slash and when to use a space? Well, if you notice, the slash is always on odd positions. So for instance, it is on first position here, first position here, first position here, and the next one is on third position, then first, third, and then fifth one has the bar, and here the third one has the bar. So we know that if it's an odd position, we should use either slash or a bar. So I will say like this, that if L is less equal K, then we'll still need 2. If when we divide now L by 2 and what remains is 1, so if it is an odd position, so 1, 3, 5 and so on, and L is not K, so then we will want to use slash, but of course I have to start collecting it somewhere. So I will define, I'll call it layer, and I make it empty first. And then so in here I will say that in that case, into my layer, I now put what it has been up to now, and the left, so that's a slash, we defined it before the code. Then, otherwise actually, if it is still an odd position and L equals K, so we are at the center of our layer, so this should be else if actually, then we want to put that central part, so our layer will become what it was, and cent, that was the name of a variable for the central part. And then else, that will mean basically that would mean that we've gone through the odd positions. Now we are left with the even positions. So we can use else in here only and just say that layer is layer and the space. So I used sp name for the variable. So this exhausts now the left hand side. So this was this inner if, and now we will say else. In a similar way, we will say that if we are now on still even position, then layer gets backslash. So that's a right sign here, the one which we define here, and then else layer gets space. And I'm ending this if. There is something that we still haven't considered, the fact that the top layer actually has just a star. So it means that in here we could have actually make it go from end with -2 to 2 only, so that this is taken care by all this slashes, backslashes and so on, and only when the tree is ready we will add one more star manually like that. But now what is happening now? Well, so far we've predefined the spaces, how many will be going where, and we've made that central layer, so the green part of the entire layer, but we still have to combine it now into a bigger structure. So we have to combine the spaces on the left, the layer, and the spaces on the right, and then we have to combine it to our total tree. So in this case, in here, so where I am out of this inner loop, I will now say first of all with capital L that my layer will be what? The spaces, then the layer, and then spaces again. And when this layer is ready like that, I will extend my tree. And now remember that I'm building the tree from bottom up. So in order for this to work, I have to add the layer first, because it will come on top of what I already had. And then after a semicolon, I say tree. Okay, let's run it and see. We should now actually get a tree. Oh yeah, this was spaces here. We should get a tree nearly complete, but without the star up there. Something is still not working. Dimensions don't agree. All right. Let's see what has gone wrong. So when you see something like this, that the dimensions are not consistent, the best way is to check what is happening in here. So what are the sizes? So what is the size of your tree? It's 4 by 19. And what is the size of layer? 1 by 17. And spaces are empty. So what has happened now? K is 9, so, and N is 10. So our spaces should actually be, oh yeah, I see. There was no space in here. I just left empty quotes, but without the space. So that's why Matlab was repeating nothing in here. So I add the space and let's run again. Okay, now it went through and let's check what we have. So you see, we actually have nearly a ready tree. The only thing we are missing is the top layer, which has the star on top. So I can add it here after the entire loop. I'll again say that tree is that top layer and tree again. So when we run it now, we should have the result. And now when I change my initial n in here, let's say 20, then we have much bigger tree, and it should also work for smaller cases. If we just put 4, so then we have a tiny tree, funny looking. If we put 5, then it's like this, and so on. So I said at the beginning that I would first write a code and then turn it into a function. So the only thing now that is really varying within this code is in here, this n, capital N. So I can make a function where I get out the tree. I will call it my Christmas, and the input is capital N. So in this case, of course, I have to end my function there, and I can call it in here now. So my Christmas of N. So then it's convenient because I can call it many times with different ends, not having to copy the entire code for different values of N. So there we go. We have the small one and we have the big one. We could try and introduce something fancy, like for instance that part of the tree would have some kind of decorations. We could try to put the Christmas balls like small O's somewhere. So I could add an extra condition now in here when I add left, right, or the center. So saying that, for instance, I can generate a random number. And now if I want, let's say, with probability 20% or 30%, these to be somewhere. So whenever my r is less than 0.3, I would, instead of using left, right, put the ball. I'll make it here. So that will be a small o. And somewhere in my code now, if we're there, so that would need an extra if inside, for instance. For instance, in here, that if r is greater than 0.3, then I do make a layer, like I add the actual slash in there, and else I would be actually making this with the ball. So we end this, and we can apply the same for the central part. So in here, and this was supposed to be sent, and for the right hand side. Sorry, that was the space. Okay, let's assume no that the spaces remain spaces. I wanted to put it in here. So for the right hand side also we could have the decorations, but the spaces should remain as spaces. Okay, so let's run it and see what will happen. So you see now I have randomly placed some of those. Maybe we can reduce the probability. And now remember that, of course, the location of those will keep changing every time we run because these are random numbers. Second thing is that we could also maybe want to prevent having them appear on the edge. So we could still add extra conditions. So first of all, I'll predefine this random limit 0.2 here, then I'll put it in the code. Okay, and I want to prevent them appearing on the edges, so for instance, when we are here, if is less equal k, and I'll say here that if this is greater, or I'll say or L equals 1. So if I'm really on the first position of my layer, then anyway I want to be having just the edge, and otherwise it can be a ball. And now the same for the right. Or here, if L, is it L? Yes, if L actually equals 2 times k minus 1. So if we are on the very far right. So let's run it again and see if it worked. And yes, now we have less of them, first of all, because I changed the limit, and then none of them appears on the edges. We can run again and distribution changes. So you can see this is just playing with arrays, and this kind of getting grasp of how to access elements of arrays, how to combine arrays together. This is actually universal for any type of arrays, whether numeric or string arrays.